All right. Well, good morning. Today we're going to talk about solving inequalities. And I know what you're saying. You're like, Mr. Miller, that's some beautiful music you brought to us today, and we do appreciate that. Thank you, Mr. Miller. But I'm going to turn it off real quick. I just want some music to get me started, because I got to teach about solving inequalities. So I need to be in the right mindset. So I think I'm in the right mindset. So let me walk back there and hit pause. Let me hit pause. All right. Hey, ain't gonna be no copyright infringement today, because that's my song. So unless I decide to sue myself, and if I ever get rich, I just might. So anyways, hey, today we're going to talk about solving inequalities when both sides of the sign are not equal. All right? And what I'm going to do real quick is just to remind you and put your mind at ease that the same operations we do to maintain equality, when the sides are the same, we do to maintain inequality to make sure that the sides are not the same. In this case, this side is bigger than that side, but it might switch if we multiply or divide by some negatives. But the basic premise is that what we have done before, we will do again. We maintain inequality the same way we maintain equality, except when we are multiplying or dividing by a negative, in which case we must flip the sign, but don't worry, we'll get that on the next problem. For now, I just want to do a real quick reminder. If I want to know what the hell that variable is, I'm going to add 4 to both sides. That's just what I'm going to do. It's who I am, it's what I'm about. And I got myself x is equal to 15, holla back. All right, up here. X minus 4 is greater than 11. Something, if I take away 4, must be bigger than 11. And another thing that's got to resonate is this. You see, there's only one answer. There's only one number in this beautiful universe that we live in, that if you subtract 4 from it, you'll be at 11. That number is 15. That only has one answer. There's only one answer to maintain this equality. But over here, it says something minus 4 has got to be bigger than 11. Well, hell, there's a lot of numbers that satisfy that inequality. There's a lot of numbers you can put over here to make sure this side is a hell of a lot bigger than that side. Or even just a little bit bigger. Like say, what if x was 20? What if it was 21? What if it was 22, 23, 24, 25, 26, 27? 28, 29, 30, 31, 32, right? 32 minus 4 is bigger than 11. 33, 34. At this point, you better stop me. You're going to be like, Mr. Miller, it's going to be one hell of a boring video if you just keep rattling away answers. Not only would it be boring video, it would also be a really long video because there's an infinite amount of answers over here. So watch this. But I want to know what it is. I mean, I can already kind of tell what it is, but I'm going to add 4 to both sides. When I do the same thing to both sides, I know I maintain my unequalness. So now I got x is greater than 15. And boom, that's the answer. X has to be greater than 15. Which means x cannot be 15, sports fans. Because 15 is not bigger than 15. Not last time I checked. Last time I checked, there was the same number. One is not bigger than the other. And so a lot of times your teachers say, graph that. They're like, graph that. It's a beautiful question. Let me indulge myself. If I'm going to graph that, I'm just going to find 15 on the number line. Okay? Positive infinity is over there. Negative infinity is way over here. And you just got to point at all the numbers bigger than 15. Now I put a little open circle there because 15 is not a valid answer. We know that it can't actually be 15. It can be any number in this great universe that is larger than 15. If it was like this, that's a different symbol. That says greater than or equal to, in which case 15 is greater than or equal to, in which case I would darken that in. But my problem wasn't like that, so I'm not going to darken it in. All right, well, hey, that's beautiful. Let's move on. I'm going to erase this over here. I'm going to erase this. There we go. Gorgeous, gorgeous, gorgeous. Now, see, I'm looking over there. You're probably like, why does he keep looking over there? Because I wrote the problems over there. See, I'm what they call prepared today. Boom, 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 boom. And I really think it's because it's finals week. It's finals week. Maybe I just need to teach somebody something. I'm just tired of watching people take tests. I'm tired of it. I'm tired of it. I want to teach. So here we go. You see, everything we do to maintain inequality, we do to maintain equality, right? It's the same. If there's an equal sign, I'm going to do the same thing. And I'll show you. Just in case you don't believe me. Just in case you don't believe me, what I'm going to do here, instead of dividing by -9, I'm going to multiply by -9 because I like that action right there. I like that those cancel or reduce to 1 for some people out there who prefer to say that reduces to 1. Now, we're going to multiply both sides by -9. Oh, come on, I didn't anticipate that. I didn't anticipate doing that. Holy Toledo, 36 times 9. Alright, so I know 36 times 10 is 360, but I don't want 10 36s, I only want 9 36s. So now I gotta subtract 36, but I'm just gonna subtract 30 and then subtract 6. So I got 324. Okay, so this is -324. Whew! Mercy! I did not anticipate that. Perhaps I should have, but I didn't. So now, look over here. I'm going to do the same thing to maintain the inequality that I did to maintain equality. Except now, look what's going to happen. Look what I'm going to do. Watch this. I'm going to flip the inequality. So this is -324. Your teacher says, throw that one on a number line. You be like, yes, ma'am. Here we go. Boom, boom, -324. Now what I'm going to do is I'm going to put a circle there. It has to be less than, so it can't actually be -324. Positive infinity is over there on the right, negative infinity on the left. So I got to point to all the numbers more negative than -324. Boom. So anytime you multiply or divide by a negative, you've got to flip the inequality. And I know what you're asking yourself right now. You're saying, Mr. Miller, do I really got to memorize that? Are you kidding me, Mr. Miller? I got to take another fact and jam it into my head now and not forget it and not confuse it? Is that what you're telling me? No, that's not what I'm telling you. You don't have to memorize it. Watch, you see, for a long time, I don't memorize these things. I don't. For a long time. And so here's what I would do. Allow me real quickly. Write down an inequality that you know for sure is true. Like 10 is greater than 4. And then ask yourself, what happens if you say multiply by a positive number? So let's multiply both sides by +2. We get 20 is greater than 8. That's still true. Like this is true and that's true. So when you multiply by a positive, you don't flip the inequality because you want to maintain the truthiness of the first statement. But what if we multiply by a -2? Then the result is -20 is greater than -8, but that's not true. Because this is more negative than that. Negative, when we're dealing with negatives, the one closer to 0 is considered the greater one. So this isn't even true. So that's why I got to flip it. And so I don't have to necessarily remember it. I can just test it and see with my own eyes that I need to flip it. And it's the same with division. If I divide by a -2, right? I'll divide by a -2. Now over here, I'm at -5. Over here, I'm at -2. And -2 is larger than -5. So again, I got to flip that inequality. So let me restate for people viewing at home, which is everybody, because the room is empty, okay? Except me. So it's not totally empty. I should count for something, right? I should count for something. I am a person, when you're dealing with an inequality, solve it the same way you would an equality, that we maintain inequality like we do equality, except when we multiply or divide by a negative, we flip the inequality. If we multiply and divide by a positive, we don't flip it, we leave it. And you can test it just to make sure I haven't gone crazy. I haven't gone all cray-cray on you. Let me hit you with one more. One more before I head on out of here and grade some more of these finals. Let's go 5. Oh, there we go. X minus 1 is greater than 3x plus 4 minus 5. All right, well, let's go get this thing right now. I like, if I'm seeing a distribution on both sides, right, on both sides of this inequality, I'm going to just do that first. I'm going to do that first, and I'm going to give myself 5x minus 5 is greater than 3x plus 12 minus 5. Now, I forgot to ask you to pause the video and try it yourself. That's what you should do. Do it now if you haven't already done it. At some point, you just got to grind it out yourself first. Let me correct you, not lead you, okay? Let me correct it, not lead it. I want to verify it, not create. So I'm going to do a quick adding of like terms on that side. So I got 5x minus 5 is greater than 3x. 12 minus 5. 12 minus 5 is 12 minus 2 is 10. Minus 3 is 7. All right, so we got plus 7. A lot of times when we're collecting like terms, the terms end up on different sides of the inequality, and we got to move them over. Just by my rule, I always take the smallest one and move it over there. I take the smallest one and move it over where the biggest one is. I make sure everything stays positive. Now, a lot of times how you look is people go like that. You subtract it out to get yourself that 0 you want. And whatever you do to one side of the inequality, you got to do to the other side of the inequality. So now what I got 2x minus 5 is greater than 7. And I'm not worried about the bottom of the board. I got my little arrows down here, but I think I'm good because I only got 2 more steps. I might just drag it up a little bit here. So now what I'm going to do is I'm going to add 5 to both sides. That sounds fun because that's going to get me closer to isolating that variable we know is x. So I got 2x now is greater than 12. 2 times x, that's a multiplication, so I'm going to divide that by 2, both sides. Remember, when I divide by a positive, I do not flip the inequality. That only happens when I divide by a negative. Thank you. Thank you. All right, boom, holla. It is. That's how we do. That's how we do. That's how we be. Your teacher might ask you to graph it. If your teacher does ask you to graph it, say, yes, ma'am, I will graph it, and thank you for the challenge. Thank you for the challenge, all right? So what we're going to do is we're going to go put a 6 right there. We're going to circle it. I ain't going to fill it in because this says x has to be greater than 6. Don't go telling me 6 is bigger than 6 because the last time I checked, they're the same. And I have a feeling, I don't know when you're going to be watching this video, but I think even in a year, 6 will still be the same as 6. 10 years from now, 6 will still be the same as 6. 100 years from now, 6 will always be 6. So the video will always be relevant, at least this part. Now, positive infinities over there, negative infinities over there. Let's go that way. Before I wrap this up, I'm going to put those tunes back on here. I hope you don't mind. Oh, there we go. Hey, it's also the holiday season. I was gonna draw you a tree, but I got lazy. I do apologize. I hope this video finds you well. I hope it finds you beautiful on a sunny day or a cold day or a warm day. I don't care what kind of day it is. just make it a good day, right? That's what I say. I say that every day. So, all right.